M code equal to an M code. So here, so this is example actually I want to give you a brief recap of this is example that we have talked about. Now for this one we have a cylindrical part. This is our raw material, and so this is our final product, and we want to have the 4 steps. 1, 2, 3, 4, 4 steps. Here you do not need to machine this part, but I want you to have this one, the smallest one, and the intermediate one, and this is the biggest one, the step. And then, for each of these 3 steps, I want you to follow. This is the length. The length for the first one is 10 millimeter, and second one is 20, and third one is 30. You can see all these 3 dimensions are measured from the very red end. Okay, the red end will be the reference. So here is a dimension of the smallest step, and here is the dimension of the intermediate step, and this is the diameter of the largest step. So I would say this is the largest step because this one I do not need to machine it at all. Okay, so we cover this. I'm going to show you again here again. So here is a 0013. So this is the program identification number, and so this is the number O. Okay, this command and starts with O, and from here you can see we want to have our first step. First step is 10 millimeter long and diameter is 17.5. So how to do that? And here we use this command. This is the number. This is number line. T53 and T53 and used to cancel any previous looping 0 point. So usually when you start a new program and you apply this T53 and to finish this one, to cancel any previously made is 0 point. And next step, T is a tool, stands for the tool. 303, that means I select my 303 tool. What is the 303 tool? Depends on how you prepare the tool. So how you prepare the tool in the tool library. So this is a selected tool number 303. And next line, this is the line number. Okay, you can see the line number they are increasing. Make sure the line number is increasing from the top to the bottom. So T57, what I want to do, T00, okay, T57 used to set the working 0 point as save, and set the working 0 point as save. And T53 is used to cancel any previously set is the working 0 point. So T53, T57. So you know that, okay? T00 means the rapid movement, no cutting. Whenever you say T00, it is rapid movement, no cutting. So this position, X20.6.0, Z0, so this is X. Be very careful. The vertical one is X. So this horizontal one is Z. Okay? So this is kind of the counterintuitive. But for our case, be very careful. This is your X, and this is your Z. T00 means from this position, without any cutting, I have a straight line. I go straight line to this destination. This is my destination number. So S500 is a spindle. S means the spindle speed is 500 RPM. M04, right? So M04 is this M code, miscellaneous code. Rotate the spindle counterclockwise. So this is spindle the counterclockwise. So this is what this statement says. The next statement, after I come to X26 or 0, right? From here, then what I do is T0, linear cutting, is a linear interpolation cutting, and from this position and to this position and to this position. If the Z is not specified, what does that mean? No. Huh?
Would you use the C previously?
Yeah. Okay, so you can see here this is the 2 coordinates, but here I only specify 1. It means that my z value does not change. You understand? Okay, so my z value does not change. That means I just only move this is vertical direction, x direction. How much I move this one. So here is only in x direction until you pass the center by 0.1 millimeter. By 0.1 millimeter, is the center is a 0. Center is a 0. You pass it a little bit, and then set feed rate to 100 millimeter per minute. So this is what a thesis statement does.
On the M code, is that machine specific? So
No.
like every machine will use different.
Every machine uses the same one. So this is convention.
Okay.
This is convention. It's just like the standardized the components.
Okay. So everything's the same.
Yeah, everything is the same. So all this is M04. Allow me to put it this way. Or M04, we have multiple is a CNC machine. For example, US made the CNC machine from Fanuc. You know, maybe you have heard of Fanuc. Fanuc, they have the CNC machine. The Japanese company, Toshiba.
Okay.
Toshiba is very, very famous, the numerical CNC machine. So they have the same thing. For Europe, I have forgot the company's name. I only focus on the Japanese and the American uses CNC machine. In Europe, French, or in France or the Germany, they have their own the CNC machines. But we specify we use the same thing for the same function, right? But it depends on the sophistication. It depends on the complexity of your machine system, and some functionalities this machine does not have.
So if you had like a function that wasn't like in the standard code, you would just do an M and your own number, and you just have to specify what that does.
Yes, that is what the CAM does.
All right.
It's the CAM, right?
Yeah.
The CAD we do the model, and CAM is what the CAM output is a G code and M code.
Yes.
The CAM is a library, okay? So they convert is a specific instructions to the general standardized G code and M code.
Right.
So this is what the CAM, computer aided manufacturing does. That's a very good question. So next step G00 Z.2. Remember, Z is in the horizontal direction. So move rapidly away from both place, no carding, G00. The movement is 2 millimeters away from the face. And then move to X50 and Z50. Look at this statement. I do not have any G code. What does it mean? It still means that the previously set G code is still valid, okay? That means for this statement, I don't have any G code. So that means I'm using this G code. Okay? Yes. Okay, so go to a safe location away from the piece. X equals 50. X is in the horizontal y direction. I'm sorry, or in the vertical direction. And 25 from the 0. So this X is 50, okay? So Z equals 50. And to change the tool. And you need to change the tool. You need to move away from the wood piece. And then you change the tool to 404. This is tool number 404. Then G57. Now G57, you need to set this is the 0 point, and then go G00 to this position and using 5,000. So this is spindle speed is 500. I'm sorry, 500 RPM. So G00 rapid movement, no carding, and G57 appears again here. So this is the 0 point. You set the 0 point. So this is a G57. G57 sets the working 0 point as safe, and G53 is cancelled. This is the previously set on working 0 point. So I'll look at here, and we go next line, G01, linear interpolation, and go here, okay, from here, Z direction, go, do you see the red color, right? Is it right? So this is where this statement go. I will go from here, my tool goes from here and to here. See, my x value does not change. What does that mean? This is my x value. My x value is a variable. That means I only change this. This is a horizontal value, which is a z value. From here and to here. That means I cut this first step. Right? This cost this costs the bigger step. This is the third step. And then I'm going to, from here, I cut another one. So this is a linear interpolation cutting, move only in z direction, this external cutting, and also at the same time, I set the bit rate to 100 millimeter per minute. So this is the longer step. Then 00 x23 in x direction, vertical direction, z 2.0 and s 500, and then you come to this 223, okay, and z 2.0 and from 500. So move rapidly away from workpiece, no cutting to location x equals 23.0, z equals 2.0. So come back here. And then another statement, T84, this is another location, D0, D2, D3. So T83 turning cycle for machining the steps, turning cycle. X, Z is the final diameter, X is the final diameter, X is the vertical direction, this way. 17.5, Z, 20 is the length from here to here. So this is the next step. T0, 200, right? This is 0, 200 finish allowance in X direction. So this is surface finish allowance. And D2 is in Z direction, and D3 is the depth card. This is what we said. And D0 is a finish allowance in X direction. D2 is the finish allowance in Z direction. And remember, D3 is the depth card of each part. We might have several parts here, right? This is what I specify. Each part, I only use this one. The reason is that I don't want to wear my tool very quickly, but I want to have multiple parts. So this we 00 Z 2.0 move rapidly away from workpiece cutting. The movement is 2 millimeters away from the face. Front face means the red face. Like the red face because we start from red face. And then next one, then still here there is no T code. That means this T00 is still valid. And we move to the tool changing location without cutting. And finally, whenever we see M30, that means that program ends. Right? So this kind of tedious, but I should go through all these things to know on how to write the code. So several points I want to mention. If in this statement, if there is no T code, it means that the preceding T code is still valid. Right? Make sense? Also, the same thing. If there is no X coordinate in this statement, that means I do not change my X direction, my X coordinate. If there is no Z, I don't change the Z direction. Right? Be very careful. Okay, so in our midterm, I'm going to give you not midterm. I'm going to give you final. I'm going to give you the very similar one. Ask you to write this is the CNC code. Question? The question, I'm going to give you another example. Now this time is a cylindrical part, cylindrical with turning. And now give you another example. Oh, now this is, look at here. So this is my raw material. It is not square, it is rectangular actually. So this is 70, this is 60. And so this is my finished part. Okay, so this is the finished part. What I want to have is that I have 3 holes. The 3 holes, the diameter is given the same, and the phi equals 5,640, and the distance between the holes and are also given. The positions are given here. Okay, so here what I want to have is that I want to have a slot here, slot, and then I just mill it. This is milling, okay? I just mill it from here to here, and to have a slot, not slot. This is because this is on edge, it's not slot. This is, we want to mill it from here to here, then from here to here, then from here to here, and until we have this part. Also, then finally we will drill 3 holes. Now you know what I'm going to do, right? So this is my original raw material, the raw material I get. Now what I want to have is this slot. This is edge slot. We call edge slot called a step here because the edge, and then we drill 3 holes. Well,
so the parts that you have, are you completely removing that material? Or are you completely removing that material, like at for example, when you mill it, do you remove some material or do you remove all? There's nothing there?
no, there's a step. There's a step.
So it's only
Yeah, move some part. We just move this slot here. This material is still there. This material is still there. Here is a slot. Here is a slot also, but this because this is boundary, right? And we will have a step here. Right? I'm going to show you. So here, so this is my X direction, my Y direction. So this is milling, right? So you know this is milling. So this is G55, we go X 200 and Y 1800. And program number 1, M06 T1, M03 RPM, and we change to 400. I'm going to give you this one, okay? So I'm going to show you what's the one. So this is M03 RPM, so T01, right? T01 is the linear, and from my original position, this is my original position, Y200, and this is X200, Y80. And then T01, X go to the X minus 8, Y0, Z0. X0, Y, X minus 8. So this is my Y, right? This is my X. So X minus 8, Y0, Z0. So you can see this is the Z, right? Z is changing. That means I'm mill down, mill down. Mill the slot, is a slot, it will be a slot. So G01, X to X minus 8, X minus 8. And to Y0, Z0. Then from X minus 8 to Y0, Z minus 08. So then I go down, right? My tool will go down. Look at here. Now my tool is here. Now my tool goes down a little bit, and the Z in Z direction, it is 12.5 millimeter. That's the depth, the actual depth of car. And then I'm going to move my tool. So here, the feeder rate is 150. And then I'm going to move X70, Y0, Z minus 0.5. This is cutting, okay, because it is my tool is going down. So let me see. this is the plate. I'm saying this is the plate. At the very beginning, this is my tool. Now I'm a tool going down a little bit. And then you can just draw it, right? You can just draw it. So here is this, you can look at this statement, all these statements, and they have z minus qualified. Okay, so here is this x direction. So here is the y direction. For x70, let me see, x70 here. x70, x minus 8, it should be here. What? X, I'm sorry. So this is y. So this is x. X minus 8, minus 8 is here. Y0, Z0, from Y0, Z0, and this is the feed. And you can go from here, X70, Y0, X70, Y0, Z0, go from here and to here. Next one, X70, Y6, Z minus 45. 7x70. So this is x70, y7, y0. Right? So x70, y0, and going down go here, and it should be here. And then x70, z60 go here. So this one is 70 from here, go to 60 here, and the z qualified. Then go back from here to here, x30, go to x30, y60, still go here, and z qualified, then x0, y40, right? x0, y40, x0, y40, x0, this is x0, x0, y0, x0. So this is a milled is a slot. Let's see, x0. This is 70, 60 is here, and then the 30, 60 it come here, and from here, and then to the x, y40, x is here, okay, x0, y40 is here, then x come back here. Okay, it makes sense now. This is from x minus 8, is from here to y0, y0, z0, y0, z0, we go here, then x minus 8, y0, y0, z, 0.5 will go down here. And then we go x70, y0, whereas what does that mean? X minus 8, y0, z0 is from here, right? So my tool, at the very beginning, my tool is here. Then I want to make the slot here. Then my tool going down. By what? By z equals 45. Z, this is the Z positive value. Understand, Sarah? So then, so the first, so this is the plate, my plate. First, my medium tool come here. Then I go down a little bit, this is minus 0.5. Then from here, I go to this part. And this part is 70, x 70. Y does not change, y 0, but z also still minus 0.5. Okay, so that means I mill this edge. Right? And then x70 to move to x70, y60, x70, y60 is here. I move here. But still, the depth is 45. After I move there, I move to x30, y60. I move here. Right? x30, x30 should be here. So you got here, the total is the 70, total is 70. And this one is 34.0. Now, here will be 70 minus 34 is 36. I just want to move a little bit here. So this is x30, y30, y60, z minus 35. Go here. Then I go to x0, y40, this again, right? So this slot, x0, y40 is here. And then I go to x0, y0 to move to have this edge coming. Got sense? So we start from here, then we have the depth, actual depth of milling. And then we go this way, this way, this way, this way, and this way. For this part, we finished this is the slot milling. And then we will drill the holes. Drill the 3 holes, and because here is a medium, okay? It's a medium, and you will use the T1. And we need to change. Tool change. And T55 X200 go to this is the addition for change. And this is the program tool. We change the tool, and now this time we use 400. What?
We change the RPM mid cut. It's like on one of the lines, you would change the RPM on it, would that work to change it while it's cutting?
Yeah, you can change the RPM. Yeah, you can change. You can. But usually here we just specify the RPM. And RPM does not change here, but we change the speed. What? And Z is the feed. Now we want to drill the 3 holes. So here, T0, Y minus 8, my tool, T0, Y X minus 8, Y0, 0, X, Y feed 150. So it's still to T01. Then I go to X20, Y50, Z100. I just directly go there. So this is a 20. This is this is 30, right? So here is a 30, and so this is a 58. From here to here is a 58, and we will know that this is a 58. So here is 30 here, 28. This is a 28, 14 here. This is a 14, and this is also 14. This is 14. And so this is 14, but this is 58 to 70. We will have 12 here, 12. This is 6 and 6. And 6 plus 14 is 20, right? Okay, so great. Let me repeat. So here is a 30. The distance between these 2 holes are 30. So from here to here, this shoulder to this shoulder is 58. 58 minus 30 equals 28, right? And 28, that means here is 1 arm. here is one arm. No, so here, this one arm, this one arm. So this guy and this guy, they are equal to each other, right? So that means 28. That means this is the 14. So this is a 14, and this is 14, right? So this is the 14, and I also know this is a 58. So total length is 70, 58, 78, 70 minus 58 is 12. So means that this is a 6, and this is 6, right? So that means the 6 plus 14 equals 20. Right? So that's the reason I move to G0 x20 y. I'm here, this one. G0 x20 y15 z10. Z10, I'm going to move my tool here. And then I come down, right? So I just move above, this is the position. And then I move down to give the actual load, actual depth card. So actual depth card, from Z10, I go to minus 10. Right? So minus 10, my drilling tool will rotate and drill a hole. Right? Okay, this is my drill a hole. After I drill the hole, I move back. See? G01, x20, y does not change as z. Now after I drill the hole, I come back. My tool is elevated. I come back. But the XY position does not change.
You would really write line 6 as just C10, because the rest of your code is the same.
So this is my original position. I just move to this system above the position, above the location, right? Then I need to drill the hole. This is my drill the hole. After I drill the hole, I need to come back. My tool, I need to retract my drill bit. Now I'll come back. After I come back, I need to move another location. So here. So that means here is 50, this is 30, right? This is 30 plus 20, 50, y15, z10. After I come to another location, above the location, I need to do a bit, is minus. Right after I do this one, I need to retract my drill bit. I have this one. And then I go to another position. Another position is 50. This is an x coordinate. This coordinate is the same. But y coordinate, I plus this is 30. So this is 15 plus 13 is 45. So I go there and then I drill it, and then I just retract my drill bit. Okay? Yeah.
Oh, super.
Okay.
Just a lot of words.
Yeah, a lot of work. So just think this way. First, if we want to drill the hole, first you need to move your drill bit above this is the position, right? Then you drill it, go down. After drilling it, you need to retract the drill bit. And in order to move to another location. Otherwise, you just drill a slot. If you do not retract your drill bit. So this program is for the 3 holes. The previous slide shows how we do this, how we mill this sugar and this slot and this sugar.
Dr. Ma,
Yeah,
you said we're going to Oliver Hall next week sometime.
yeah. That's good.
Are we just looking at the machines, or would we use it?
First, I want you to have a sketch idea how to operate it.
So you're going to demonstrate?
The Franco will demonstrate. If the time permits, we might do something hands-on. Right? So ask. We have several groups.
I was thinking if we're going to have a small group like this, like the ones there.
Yeah.
That'd be kind of cool.
For hands-on experience, the smaller the group, the better. Right?
The CNC with a tool changer, could you do this all as a single program, or would you still have to create multiple?
Depends on, for this case, because we use different tools.
Yeah, but if it had a tool changer built into it, where you just switch out which tool it was using.
Yeah, you can
Would
switch.
that just be one program then?
That's a good question.
maybe.
Yeah, maybe. It depends on what kind of tool library we have.
Okay.
Yeah. So here, okay, so here actually, so this is the following slides just to show us, just what I just explained to you. Okay, so see, at the very beginning, guys, at the very beginning, our tool is here, and this is the bottom left edge. This is our tool. And then I will go here, this is program, identification number, and then we change the tool. So this is actually what I show you, okay? Then we have, this is the start rotating the spindle clockwise with 400 RPM. I think we go to X minus 8, Y0, Z0. We go to save position with this feeder rate. And then I will go to the Z direction, go in the Z direction. That means get the depth of call, the axle depth of call. And lower the end mill to determine the depth of call. So this is this one. After here, and then we just move from this using G0 from this position to our X70 here, Y0, still Z does not change. And we have this shoulder, we have this is this edge. Right, so this is a feeder rate is 75. And so after we get here, we just move up using G0. This time X70, Y60, and Z the same, and using the same feeder rate for this edge. And then we come back, go to X30, Y60 here, XY feed 75. And then we can have this is a straight slot. And this is a straight slot from here. I think from to X0, Y40 is here. And we have this slot. And then we just have this shoulder. So this from here to X0, Y0 with the same Z value from here. And so this is the repeat 7 times block from N003 and to N009. Several times blocks with increment of offset Z, the -5. So we repeated 7 times from N003 and to N009. Right? Repeat 3 to 9. And the spindle off M05, the spindle off because we are going to change the tool. And then this program ends. The program number 1 ends. Second, we change the tool for filling the holes. We already come back here. And then we want to the tool change, the program identification number, program tool. So we have this M026 and tool change tool with diameter and 6 millimeter. So this is tool with diameter 6. And so RPM is specified on 400 spindle clockwise. And go to save position. Go to save position here. It's still -8 Y0 X Z0. And then we need to go X20 Y50. Our first location of our first hole. Go there and with Z10. Okay, Z10 that means we elevated our drill bit just to avoid and to scratch on the wood piece. And then we lower the Z value. Z value means just vertical to our screen. So and lower Z value to 10 and drill the hole, drill the first hole. And then we go to we just retract our drill bit. If X, Y does not change, Z changes from -10 to 10. And then we go back to our second the location of our second hole of X50. And then we go down, Z going down. Then we retract our drill bit. And we finish our second hole. Then go to our location of third tool, drill hole, which y equals 45. And go down, Z, then retract the drill bit and finish here. Up to here, we finish our third hole. And then M5, 05 speed on. So this is M02 and the program end.
Just one.
Yeah.
Is there a preview of the program you write before you actually machine it? Like I'm just imagining like what if like you if you make a mistake in programming, is there a preview before you send it out so they actually get machined?
Usually, that's a good question, okay? That's a very good question. So if we write a new program, the first thing we need to do is we will run the program without any workpiece. You know what I'm saying?
Okay.
Without any workpiece, but we can see how our tool will be moving. So we will have an idea whether our program is wrong or right. That's a very good question. Okay? So usually, if you write a new program, never ever just immediately use a new program to machine something. You need to try, you need to, without any workpiece, just to see how the tool moves. Okay? If no errors, you can just machine something.